There we go. So we are back, as I said, with the... Which paper is this? The Edexcel... Let me get the actual terminology. Pearson Edexcel Level 3 GCE paper from 2023, and we're doing paper 2, Pure Maths 2. So we've done, honestly, so much differentiation and integration. And now we're just doing algebraic manipulation, I think, for the first question. But that should be nice and chill. As before, I'm back on the Remarkable, and the Remarkable software is being a bit silly, so we're going to end up with these like lines when I'm hovering. Apologies about that. That's just me holding the pen too close. Hopefully it will be fine. So we're starting off with the curve C has parametric equations. X is t squared plus 6t minus 16. Y is 6 log t plus 3, where t is greater than minus 3. Show that a Cartesian equation for this, so the parametric equation is x and y both in terms of something else, and our Cartesian equation is x in terms of y, or y in terms of x. And we want it in the form y is a ln x plus b. Well, these two are already pretty close together, so hopefully we can just manipulate them, move them around, and swap it. So what I'm going to try and do is get, so part A, I'm going to find t plus 3 in terms of like x is my plan. And that should be, let me sub it in. Hopefully it will be x plus something. So what do we have? We have x is equals to t squared plus 6t minus 16. And what can we do with that? We could complete the square with it. Because that would give us the t plus 3, actually. So that would be t plus 3 all squared. And then we need to basically, so this would be equivalent to that expression. So we need to figure out what we need to do to get from 9 to 16. So we just can subtract the 9 that we would have got from doing this expansion, minus 16. So that gives us t plus 3 all squared minus 25. Okay. And then we want this in terms of, remember, t plus 3 equals something. So we can do x plus 25 is equals to t plus 3 squared. So we get t plus 3 is equals to x plus 25 to the power of a half, or square root. But I'll do power of a half for a reason that will become apparent. So because we're trying to get things in the form y is equals to a ln x plus b. So we're going to come in and sub this in. Into the star. So we get y is... Oh, sorry. Sub it into this one. Okay. You can't see the top. That's annoying. There we go. I'm going to move it anyway. So we get y is 6 ln, and then it was t plus 3, but now it's going to be x plus 25 to the power of a half. And with a log law, we can do ln of x to the a is a ln x. So that means that we can take that half out in front. And that gives us y is 6 times a half ln x plus 25, or in total y is 3 ln x plus 25. Okay, so that is in the form here. And we can be even more pedantic if we really, really wanted to and say that A is going to be equals to 3, B is 25. Okay, but the expression they've asked for is the y is 3 log ln x plus 25, so we should be all right with that. Hey, thank you for the follow. Welcome in. Okay, so part B, then. The curve C cuts the y-axis at the point P. Show that the equation of... Okay, so C is this curve that we had from before. Let's get the whole question up. Yeah. So the curve C, which is the one that we have, which we now have in this nice form of y is 3 log x plus 25, cuts the y-axis at a point P. Show that the equation of the tangent to C at the point P can be written in the form ax plus by equals c ln 5, a, b, and c to be determined. Okay. So we have that it cuts the y-axis at P, which means that so cutting the y-axis, crossing the y-axis is when x is equals to 0. Y is going to be 3 ln 0 plus 25. 25. So these are our coordinates for P. Just from subbing them in. Do we want to leave it like that? No, we can... So something that's sort of given me a clue, a hint to what we want to do is we've got this log 5. And I can get to a log 5 really quickly from a log 25 using this power law that we had before. So what I'm actually going to do is I'm going to write this instead of 3 ln 25, it's 3 ln 5 squared, or 6 ln to the 5. So I'm actually going to write this as 6 ln to the 5. Okay, so all that does is in the same way that we had before, where it was x squared, now it's 5 squared to give us 25. And that then we can pull out the front, multiply through by the power that was there. So our point P coordinates are x is 0 and y is 6 ln 25. Then we want to find the tangent at that point. So we have y is, as we had before, 3 ln x plus 25. So we need to know what dy dx is, okay? Because that'll give us our gradient at the point. So the derivative of the log is... Logs go to -1. Yeah, because -1 goes to log. Always get those the wrong way around. So the derivative of log goes to -1 over. So we can leave the 3 alone. And what we get is we do the entire thing inside. If x had powers or anything, it would be more complicated, but it's not. So we get 3 over x plus 25. Okay, but remember, we want this evaluated at the point P, which is where dy dx evaluated at x equals 0, which is 3 over 0 plus 25. So we get 3 over 25 is our gradient at that point. So we have that the gradient of this is 3 over 25, and we have the point P is the coordinate 0 and 6 ln 5. And then the last thing that we need is the equation straight line, and I'm going to use y minus y naught equals x minus x naught as my general expression for my equation of my line. Because it's a tangent, we know it's a straight line. And then we have the m is the gradient. So this thing is m, this is x naught, and this is y naught. So all we need to do is plug it in. So we get y minus 6 ln 5 is 3 over 25 x minus 0. Multiplying all of this up, we know that we're trying to get it in the form ax plus by equals c ln of 5. Okay. So we get 25y minus 25 times 6 is 150. ln 5 is equals to 3x, and then the 3 times 0 goes to 0. So it's not too bad. So that leaves us with, remember, we want the ln 5 on the other side. So 25y minus 3x is equals to 150 log 5. So that's the equation of the tangent of the curve C as it crosses the x-axis, y-axis even. Oh wow, they give a lot of pages for that. Okay. Question 10. We have a function where k is a positive constant. It's 3kx minus 18 over x plus 4 x minus 2. There's going to be more factorization. Express f of x in partial fractions. Oh, I love partial fractions. In terms of k. Hence, find the exact value of k for which the integral of f between minus 3 and 1 is exactly 21. So first step should be quite chill. We need to express it in terms of partial fractions. That is just sort of rote memorization of the formula, and then figure out what goes where. And then find the exact value of k for which that is solved. It's going to be plugging it into that expression and then working backwards to solve it for a value of k. So part A, we had f of x is equals to 3kx minus 18 over x plus 4 x minus 2. Okay. So partial fractions, it depends what's on the denominator. Nearly forgot that. Oh no, functions already. No, it's going to be okay. We've got this. Okay. So we have our numerator and our denominator, right? So we look at our denominator and we see what powers that are already there. So if it was just one expression, if it was just like something over x, that would be fine. But we've got a quadratic term here, right? When we multiply this out, we get the x and the x, that gives us x squared. So we need to separate that out. So what we do is we write each of the brackets in the denominator as their own fraction with something on the top. Just jumping in to say hello between meetings. Hope everyone's doing well. I hope you're doing well too. Thanks for coming in and saying hi. Very appreciated. So if one of these had a power term, we'd need multiple of them. And it's sort of a case of sort of vaguely memorizing what happens. But basically, it's looking at getting simple expressions on your denominator and then taking each one of those as their own fraction. I'm sure there's like a nice way to explain it more than just I remember it. Some of the pure mathematicians, I'm sure, can fill us in. So we then need to sort of figure out what A and B are going to be. So in order to do that, we then have to sort of convert this side back into a single fraction by doing that addition, and then comparing sort of what's missing on each side. So what do I mean by that? Well, if we expand out this term, if we ignore this bit for the minute, so we just look. So if we had 3kx minus 18 over x plus 4, x minus 2. And that is definitely equal to a x plus 4 plus b over x minus 2. To do something a bit more interesting with this, what we want to do is multiply up. Basically try and get rid of the denominator, okay? So we're going to multiply both sides by this x plus 4, x minus 2. And what does that do? Well, on the left-hand side, when you multiply everything by its denominator, you just get what's left on the top, right? So if this expression here comes and multiplies here, it cancels out. So we're left with the 3kx minus 18 on the left-hand side. On the right-hand side, we would have the equivalent of a x plus 4 over x plus 4 times x plus 4 x minus 2. And these would cancel, right? We have it on the top and we have it on the bottom. So we're just left with the x minus 2. And then similarly, we do the same thing with b. So we would multiply this expression by x minus 2 on the top, which would cancel it out. And we'd be left with x plus 4. Good mathematical day to study is going to stay quiet listening. No worries at all. Welcome in. Chill out. We're having a good time. Okay, so now we have an expression that's not a fraction, and we can do some chill things with it. So again, leaving this side alone, we expand this out, and we get ax minus 2a plus bx plus 4b. And I wrote that in the absolute most cursed way possible. B. There we go. And then what we do is we compare coefficients. So compare coefficients. And what that means is we start by looking at x to the naught. Okay, so constants. Or terms that have no x in them at all in the expression. So the terms that have no x are, I need like a third color, blue. So the terms that have no x on this side is minus 18. And then this ax has an x in it, so we have the 2a, bx has an x in it, and we have the 4b. And when we have an equation, when we say the left-hand side is equal to the right-hand side, the stuff is the same as well, right? You can't have an apple equal to a banana. So the number of apples on one side and the number of apples on the other have to be the same. And the number of bananas on one side and the number of bananas on the other have to be the same. So the number of constants, or the amount of constant, has to be the same because x is going to do its own thing. So looking at the constants, we have minus 18 is definitely going to be equals to minus 2a plus 4b. And then we do the same thing with x to the power of 1, which is just x. And here we have the coefficient in front of. So this is where the coefficient bit comes in, is like the amount of x has to be the same. And we could put the x there, but they'd all have x in them, so we can cancel them out. So we get 3k on one side, a from here, and b from here. Okay. So now we have two equations with two unknowns. So this, simultaneous equations. And specifically, technically, we have three unknowns because there's that k term in there, but we're ignoring the k for a bit. We're sort of disregarding it because we know that that's unknown. The thing we're trying to solve for, the thing we want, is the expression in terms of k, so we can ignore it. So a and b are the unknowns that we need to solve for. So I'm going to call this one 1. Let's go back to black now. This one 1 and this one 2. So we're going to look at 2 first. So I'm going to do A is 3k minus B. Am I? Yeah, I am. Okay, and then, so I've just rearranged 2, and I'm going to substitute that into 1. So that gives me minus 18 is minus, and then where I had a 2, where I had the A, I'm now going to have 3k minus B plus 4b. So I get minus 18 is equals to minus 6k plus 2b plus 4b. So I get minus 18. I'm going to bring the k over, so I just have b on one side, plus 6k is equals to 6b. Now, all of those are divisible by 6, so that leaves me with minus 3 plus k is b, or writing it nicer, b is k minus 3. And then what we need to do is then substitute back into 2, okay? So A was 3k minus B, which was 3k minus k minus 3, or 2k, 3k minus 1, minus 3 is plus 3. Oh dear. I'm going to copy those over to the other page so that I can do it quickly. Okay, so this gives me, we had f of x equals to something over x plus 4 plus something over x minus 2. And it was a and b, so it was 2k plus 3 and k minus 3. I'm done with those, so I don't need them anymore. Okay, so that's our expression, right? So we went from this expression where we had this mixed fraction, or fraction with a complicated denominator. Now it's in partial fractions, so it's separated out. So we had a over x plus 4, b over x minus 2, so we solve for a and b, where k is some positive constant. We then had part b, where we get told that minus 3 to 1 of f of x is equals to 21, and essentially we're told to find k. So what I'm going to do is I'm just going to plug this new expression of f of x into the integral. So I get from minus 3 to 1 of 2k plus 3 over x plus 4 plus k minus 3 over x minus 2 dx. And we know that it's equal to 21. So we can keep that constant. Thank you for the follow. Very appreciated. Following, but the ad interrupted and now you're lost again. Oh no! Okay, so what we had was this mixed term. We wrote it out in terms of a and b here, and then multiplied both sides of that expression by x plus 4, x minus 2. And that gave us 2 equations by looking at what had terms that didn't have an x in them. So here, here, and here. Sorry, the stylus for pointing is a bit hard. And then the underlined with pink terms all have x in them. That gave us simultaneous equations for a and b, which gave us the top expression. I really need to get something that tells me when ads are running. And now we're trying to solve it as an integral. So this is an easier way of looking at it, maybe, is because we're summing, we can sort of do each integral at a time, because it's the same as saying 2k plus 3 over x plus 4 dx plus the integral of minus 3 to 1 of k minus 3 x minus 2 dx is equals to 21. And even, so it looks really complicated, right? Because you've got stuff on the top and stuff on the bottom. But the stuff on the top, k is a constant, right? We're not integrating with respect to k, we're integrating with respect to x. So that is just a number. And we can pull that out. We don't have to integrate that too complicated. So what we can do is do 2k plus 3. And then we're just doing the integral of 1 over x plus 4. And similarly here, k minus 3, that's just a number. Minus 3 to 1, 1 over x minus 2 dx. And here I've just written the dx. Here I've written the dx over x plus 4, and here I've written 1 over. These are the same thing. Just sometimes if we're feeling lazy, we don't write the 1 over and we just shift the dx in a bit. But they're exactly the same thing. They're 1 over those terms. So 1 over x plus 4 is the same as saying x plus 4 to the minus 1. And when we integrate, we add 1 to the power. But if we add 1 to the power, we get x plus 4 all to the power of 0, which is a constant, so that sort of breaks things. So the integral of 1 over x is log of x, which is the opposite of what we just did in the previous question where we had to differentiate log of x. So that's where that sort of comes from. Well, that's how I remember it, is like, right, if we're adding 1 or subtracting 1 to the power, we need something else. So it goes to the logs. So that tells me that we get 2k plus 3 log of x plus 4 evaluated between minus 3 and 1. And k minus 3 log x minus 2 evaluated at minus 3 and 1. Again, we're equals to 21. So we get 2k plus 3, and I should have put brackets there. So we get log, evaluating this between 1 and minus 3, is doing ln of 1 plus 4 minus ln of minus 3 plus 4. So you sort of take the difference between the two. And we do the same thing here. K minus 3. And that's ln of... okay, so 1 minus 2 goes to minus 1. Minus ln of minus 3 minus 2 is minus 5. Again, is equals to 21. So simplifying this, you get 2k plus 3 log of 5 minus log of 1. Yep. Plus k minus 3 log of minus 1 log of minus 5. Is that right? But Kat, you can't evaluate log of minus 1 or log of minus 5. This is so true. Which is why I was stumbling at it. Okay, so what can we do? So when we take the logs, I've been putting brackets, and realistically what I should have been doing is putting moduli. Because what we can do is because, so again, if we think about what log looks like, right, log is this function here. It gets super, 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 super close to 0, but it's called asymptotic, so it never quite touches it. So there is no way for me to be, say, over here and to evaluate ln of x. I didn't, but they're just so good at it. So we can't possibly take it in. So when we do ln of something, realistically what we're actually looking at is the modulus of these expressions. Okay, and modulus just means if it's positive or negative, you just take the positive value of it. So if we had the graph, I'll do it properly because I'm going to draw 2 of them. Okay. the line y equals x, right? Every value of x goes to every value of y. Same thing. But now, instead of going to, so this is y is mod of x. So here, -2 would go to -2, but now -2 goes to 2. And then, but so does 2. 2 also goes to 2. Okay, so instead of the negative, we just take the positive. So if we do that, that actually makes our lives so much easier. So let's just disregard all of that bit for a minute. And take this bit over to a cleaner page. Okay, so evaluating them with moduli, we get 2k plus 3. That one stays in its normal brackets. Log of... okay, so x plus 4, where x is 1, so that's 5. Minus log of 4 minus 3, so that is actually 1. Plus k minus 3 ln of... So 1 minus 2 is the modulus of -1 minus ln the modulus of -5. Don't know why I tried to write 25, 21. So we get 2k plus 3. And here we get ln of 5, ln of 1, as it was. But now here we get ln of 1 minus ln of 5. And I believe that should be chill. Expanding this out then. So we get 2k ln 5. I can see that something's going to cancel, but I'm terrible at doing signs quickly in my head. So I'm going to do it in full. Plus 3 ln 5. And then we get minus 2k ln 1. My L's, my 1's, and my brackets are all starting to look very similar. Minus 3 ln 1. Plus k ln 1. Minus 3 ln 1. Minus k ln 5 plus 3 ln 5, all equals to 21. I think my signs are right on that. Okay, so one more thing that actually would have made my life easier if I'd done it before, but I just wanted to write it out in full, is I keep drawing my log curve like this. This value here is 1. Okay, so the log of x crosses the x-axis at the value 1. So that means that ln of 1 is equals to 0, so I never have to write out those ones particularly drastically ever again. So actually just this term goes away, this term goes away, this term goes away, and this term goes away, because they all disappear and they go to 0. They are 0. They don't even go to. So that gives me something much nicer. Every term on this side now has log of 5 in it. Okay, so every single one of them, so that I can actually put it back and I get 2k plus 3 from before, plus k minus 3. Sometimes you need to work through the questions to figure out what the answers are, you know? Equals to 21. ln of 5 is 3k There was a -5. So that's actually k plus 6. So yeah, because of this -5 here, we got there. Thanks, Rob. Is 21. So k plus 6 is 21 over log of 5. So k, which was the thing that we were trying to get to in the end, 21 log 5 minus 6. And hopefully it doesn't tell us it wants it in decimal places. No, it says find the exact value. So exact value, we can leave it alone, because if we simplified it, it would become an approximation. It wouldn't be exact. I 100% would have lost marks in that question if I was doing it in an exam condition. Oh, there's a lot of steps. The steps are all right. The steps are quite nice individually. You're just like, okay, rearrange an expression, solving quite a nice integral, so some simultaneous equations, and determining a partial fraction. But there was a lot going on there for, 7 marks. But that's 10% of the total exam. I forgot how many marks this thing was out of in total. For context, this exam is a 2-hour exam. 2-hour exam out of 100. Oh boy. All right. Let's go on to question 11. See how many errors we make on that front. Oh, wait, question 11 continued. I'd like to actually see question 11. There we go. Ooh, we got some shapes. Nice. Okay. Tank in the shape of a cuboid, so it ain't square, is being filled with water. The base of the tank measures 20 by 10 meters, and the height of the tank is 5 meters, as shown in figure 1. So first thing to note, it gives us the drawing, which is lovely. And it's also given everything in meters, which is the nice one, because when I can see that it's going to be going on about height and volumes and stuff. If at any point it asks us to do things around sort of meters per second, or looking at speeds or looking at flow rates or something, meters is the units that we want to be working with, right? They're SI units. Sometimes what they'll do with questions where it starts giving you like real things is it'll give you things in hours or minutes or kilometers or centimeters, and you also have to do a conversion. But normally meters, seconds, kilograms, all quite nice to work with. So tank in the shape of a cuboid being filled with water. Base of the tank measures 20 by 10. Height of the tank is 5, as shown in figure 1. At time t minutes after water started flowing into the tank, the height of the water was h meters, and the volume of water in the tank was v meters cubed. In a model of this situation, the sides of the tank have negligible thickness, so we can assume that the water expands the entire size that it's being given. And the rate of change of v is inversely proportional to the square root of h. I work with feet in inches, so meters is so much more tiny. Yeah, feet in inches is a hard one to remember. No worries, Nit. I'll see you later. Oh, thank you for the follow. Welcome in. Hope you're enjoying. Okay. This question is actually, I think, a full page. So we'll read through it all and then go for it. But first thing to notice, we've got inverse proportional. So V is inverse proportional. So 1 over the square root of H. So H square rooted. That's what that sentence is giving us. This one, the top bit just tells us that it's assume that's the size of the water. Don't worry about taking anything off for inches. Scared of maths at this pit? Don't be scared. We're here together. We'll get through it together. Also, that's a really cute emote. So thank you for sharing that. Welcome in. Sorry, I appreciate saying don't be scared isn't actually that helpful if it is intimidating. But I hope to make it less scary for you. In the same way that I find things scary, and it just takes a little bit of exposure therapy and a little bit of kindness, and we'll get through it. That being said, if anyone sees a spider in the behind me, no, you didn't. Nope. You want to talk scary? That's scary. Okay. given initially the height of the water in the tank was 1.44 meters, exactly 8 minutes after we started flowing. So, okay, so this is, so initially is a t equals 0 thing. All right, so when t equals 0, what do we have? So we have dH/dt. So we have, this is telling us that we're going to have like the height as a function of time. Is sort of the thing that we're going to be working around. You can handle a spider? Okay, we can divide and conquer this then. It's going to be okay. Yeah, so we're going to have the height as a function of time. So h at 0 is 1.44. And h of 8 is that's off the screen. Apologies, my screen is ever so slightly taller. H of 8 is 3.24. So we have two different values of t and two different values of h that we compare together. Snakes you need to worry about. Ooh, yeah, no. I haven't been around them enough to comment. I think it's like the sudden movement. Sorry if this is not a happy conversation. We'll move away from it in a minute. Evening, welcome in. Yeah, sudden movement or things in dimensions that I don't expect them to be in. Snakes are cute though. Yeah, I vibe with the concept of snakes. I think I've held one. I don't remember fully, but I feel like I have vague memories of being a small child and like my local library bringing in animals. And I think there was a snake. And I think I've touched a snake. I'll ask a grown-up at some point. Live in Australia, which everyone thinks means everything is trying to kill you, which is somewhat okay. You have a higher proportion of things which can kill you than we do in the UK. I think I'll concede that they maybe don't want to, but they can. Sharks are dogs of the sea. I refuse to change your mind. Accurate statement. 100%. Others are just skits. Yeah, that's fair. That's fair. Okay, back to the equation. So the first thing that we're being asked to do is just show that this expression, so the change in h over time is proportional to this thing, which is something that we can get to. We then get given these additional informations. Use the model. So the model here is sort of this thing. Okay. So use everything we've built to get to that point. To find an equation linking h with t, giving your answer in the form h is 3/2 a t plus b, where a and b are constants to be found. So we need to find a and b. Then find the time taken from when the water started flowing into the tank for the tank to be completely full. So here we get told that the entire tank is 5 meters. So we're looking for at what time is h 5. Which this expression will give us, right? We plug in h is equals to 5 here once we know a and b, and we should be all right. That's the plan anyway. So we'll start from the beginning. We've got this proportionality. We've got size. And we need to show that the rate of change of h is inversely proportional to the square root. Okay, let's do this then. Okay, so first things first, let's find some relationships. So part A. So we're looking for dH/dt is equals to what? We get told that v is proportional to 1 over the square root of h. And actually, we can work out v in terms of h. So v is the volume. And it's the volume of water, right? The volume of the water. So what we have here is base times height. So it was what? 20 by 10 by h. So the volume of the water is 20 times 10 times h, or 200h. Flow rate was linear, but I guess witnessing the flow makes sense. So the flow, I think, is constant. We're not assuming any sort of variation in that, but the height of the water is going to change over time. And we don't know. Actually, we don't know that it's linear. I suppose we're assuming that it's not. Yeah, there's nothing in the question that seems to indicate. And if anything, it has this, actually, yeah, so it's this bit in particular that indicates otherwise. So because the volume isn't proportional to the height. The volume has a relationship to the height. That's why it's not at a constant rate. No, it could be. Normally they have equations in mind and then they find reasons to, you know, they work backwards to a real reason. Anyway, we'll go with the information that we've been given and not question how realistic a model it is. This is the safest option. Okay. Take my word for it. Dangerous game. Okay, so we have the volume of the water is 200h. So because v is now a function of h, what we can do means that we can take dv dt. So how does the volume change as the height increases? And this is actually, so that is linear, so it's just 200. So the volume as the height changes, it does have some positive gradient, but it's just 200 there. We then have the rate of change of v. So that's actually wrong. It's not v, it's the rate of change of v. So the rate of change of v is dv dt. Is that under? No. The rate of change of v is what we are told is inversely proportional to, so some constant of proportionality is k over h. So we now have two things. Where do we want to get to? dh dt. Okay. So dh dt, we can do a chain rule here and do dh dv times dv dt. And it becomes a question of we need to find what dh dv is. Well, if dv dh is 200, dh dv is 1 over 200. Like, it's not exactly a fraction, but if I manipulated the equation, I could then find the derivative and it would just give me 1 over 200. So we get 1 over 200 times by some value k, which was our proportion of constant of proportionality over h, which is, I think the term it wanted to use was lambda, so lambda over h. So dh dt is lambda over h square rooted, where lambda was some k over 200, where that is also just a constant. So we can swap a constant multiplied by a number by just a different constant. So we don't need to worry too much about that. But it is some value lambda over square root of h, which is what we were asked for, I believe. Then we get given some values, and we get told to link h to t, so actually find the expression. So in order to do that, we sort of need to find out what lambda is, and then we can integrate the equation. So goal, step 1, find lambda. So puppy. Step 2. For h. Step 3, profit. Okay, that's the goal. So the two values that we had were h at, where's my other copy? H at 0 is 1.44, and h at 8 minutes. So we need to be careful with our choice of t here. So I can stick with 8, but I'm now saying that t is measured in minutes. So if at some point I do something in seconds, someone clock me, and then because I've changed my values. But we can stick with minutes because I don't think we're doing anything with flow rate. And that was 3.24 meters. So dh dt is lambda over root h. So if I integrate this, I get the integral of lambda root h dh is the integral of lambda dt. So we do, it's integration by separable equations in A level. Feels like it should be. And again, because lambda's unknown, I can just swap the signs around as and when I see fit. So this is h to the half dh, and this is just some constant with respect to t. So the constant gets multiplied by a t, and then we get this other constant that comes in. And on this side, when we integrate a power, we add 1 to the power, and then we divide by that entire power. So h half plus 1 is 3 over 2. And then we divide by 3 over 2, so we multiply by 2 over 3. And then what it wants is h on the one side, and then everything else on the other. But let's plug things in first, because I think that's going to be easier. So we'll sub in b equals 0, h is 1.44. Thank you for the follow. Welcome. Okay, so we get 2 over 3, 1.44 to the 3 over 2 is lambda times 0 is equals to c. That's a gross number. Let me get my calculator out. We are allowed calculators for this. 2 over 3 times 1.44 to the power of 3 over 2. So we get c is equals to 1.152. So 2 over 3 h to the 3 over 2 is equals to lambda t plus 1.152. And then I believe the only thing left to do is find lambda. So we plug in t equals 8 for h is 3.24. Okay. So on this side, I now get 3.888 is equals to 8 lambda plus 1.152. Rearranging, 8 lambda is 3.888 minus 1.152. 2.736. So lambda over 2 is equals to 2.736 over 8, which is 0.342. So that gives me a final expression of h to the power of 3 over 2 is equals to 0.342 t plus 1.152, which hopefully is in the right form. For some reason, my brain thought we needed an exponential in here, but we didn't. Okay, so we found a value of a and we found a value of b. So lambda is just a Greek letter. In this case, it was just the constant that we were told to use from here. Sometimes when we are using, we need more variables that we can handle. Okay. And then the final part of that question that I've already forgotten is hence take the time, find the time taken for the tank to be completely full. So the tank is completely full when on that diagram it was all the way up to 5. So what we're looking for is part C, sub in h equals to 5. And that gets us 5 to the power of 3 over 2, which is going to be something gross. I'm going to write it out in full for the minute. So 5 to the 3 over 2 minus 1.152 all over 0.342. So I've just rearranged that equation. I'm just going to plug that entire thing in my calculator. Five to the power of 3 over 2 minus 1.152 all over 0.342. If I could type on the calculator, that would help. 0.342. Which is... not right. Oh, for some reason I just decided that we didn't need a 2 over 3 in front here. There we go. Is the rate of flow given? No, unfortunately not. So we're sort of doing everything knowing that there's some variation there, but we don't know what it is. Okay, so 2 over 3 that. So now if I apply times this by 2 times, that should give me, there we go, 18.43. Two decimal places. That's a while. Given that it takes, so I suppose, yeah, it takes 8 minutes to fill up over a third. It's a weird flow rate. It's a very, very strange flow rate. Oops. Okay. Question 12. We didn't get these sorts of questions when I was in school. Number of subscribers to 2 different music streaming companies, which were not a thing when I was a kid. I feel old. Math. Oh my god. Yeah. Is this what we're doing? Probably on par for some. Honestly, sometimes, yeah, it's like someone downstairs is just turning the taps on and off. Someone else is trying to boil the kettle and, you know, your flow rate's all over the place. That's what's happening. So we have question 12. A number of subscribers to 2 different music streaming companies is being monitored. The number of subscribers, NA, in thousands, I do wish it would stop dropping. There we go. Number of subscribers, NA. Spotify existed when we were in school. It started in 2006. They weren't talking about it in our GCSE papers. And how popular was it? I'm sorry, LimeWire was being used in 2006. I refuse to believe Spotify was popular until like 2012, maybe. In thousands, company A is modeled by the equation NA is the modulus, so that's what we were talking about before, of like positive only values, t minus 3 plus 4 for t greater than 0. Where t is the time in years since monitoring began, and the number of subscribers NB is modeled by NB is 8 minus 2t minus 6. If t was greater in time since, is the time in years since monitoring began. Okay, so we've got two different variables. We've got in thousands, and we've also got in years. So we're talking about thousands, n is in thousands, and time is in years. Figure 2 shows a sketch of the graph. Where can you see up to? Yeah. Figure 2 shows a sketch of the graph of NA and the graph of NB over a 5-year period. Use the equations of the models to answers part A, B, C, and D. So we're not allowed to draw on the graph and just be like, C. We have to specifically use these. Find the initial difference between the number of subscribers to company A and the number of subscribers to company B. 20 million users and 5 million subscribers in December 2012. I can't open. Spotify number users over time. So it started, yeah. Anyway, Apple iTunes, yeah. Just thinking like where I used to listen to different albums, and I'm like, we used to rip the CDs, cassette tapes back in the day. Okay, anyway, let's look at the question. So find the initial difference between the number of subscribers to company A and the number of subscribers to company B. So when they both started. When T is sometime T, company A reduced its subscription prices and the number of subscribers increased. Suggest a value for T given your answer. Now, so this is explicitly giving a reason, use the equations. What we're not allowed to do is look at this and be like, ah, well, they saw an increase in number of users at a point. We know there's going to be a number of users at a point because they've sort of given us something in a figure where this, like, right, there's something changes. We can't just point to the graph. So we have to give something about the equations that tells us what that value is. Find a range of values for which NA is bigger than NB. Again, using the equations. So we're not allowed to just look at it and be like, well, this much, as much as we want to. And then finally, find the range of values and state a limitation of the model used for company B. Okay. And again, we're all looking at the equations. The graph is there to sort of help with intuition. It is not there for us to use. So we're going to write out our expressions again. So immediately got it wrong. T minus 3 plus 4. And NB is 8 minus 2t minus 6. How do we solve P as NP? No. I'm not paid enough for that. Unfortunately. Okay. So part A. was find the initial difference. So when t equals 0, so NA of 0 is modulus of -3 plus 4, which is 7. And B of 0 is 8 minus modulus of -6, which is 14. So the difference in users is equals to... But yeah, okay, so going back to the question at hand, we've now checked ourselves. We have modulus, so we're taking positive values, right? This is the absolute value. This is, if it's negative, switch it to a positive. So that's -6. This thing becomes +6, so 8 minus 6 is 2. So the difference in users is 5. But remember that this is in thousands, okay? So I don't actually want an equal sign there. I get that. So it's 5. I know how many zeros are in 1,000. 5,000 subscribers. Okay, part B. Ooh. Part B was suggest a value for T. So T is when company A reduced its subscription prices and the number of subscribers increased. So we're trying to find a point when NA suddenly starts increasing. Now we know that NA has sort of this thing going on. So essentially what we're looking for here is this point here. So our expression is T minus 3 plus 4. So what do we have? We have, it would be the point where it changes. Thank you for the follow, welcome in. So the point where it changes would be, right, so this thing is going to get, as T increases, so T is 0 and it starts at 7. And as T gets bigger, that -3 is going to dominate. So it's going to get smaller and smaller and smaller and smaller. And then eventually, apologies. Okay, not my problem. So until T is equals to 3, and then the T is going to be bigger than 3. So basically, it's going to change. When T minus 3 is equals to 0. So the vertex for the point when the absolute value T minus 3 is equals to 0, which happens when T minus 3 is equals to 0. So T is equals to 3. So when T was equals to 3, A started increasing. Because then once T is bigger than 3, once T is equals to 4 here, this -3 becomes positive again. And then it starts adding. And then as T gets bigger, it gets bigger and bigger and bigger and bigger. Part C was something. Find the range of values which NA is bigger than NB. Give your answer, excuse me, in set notation. Okay. Aw, thank you so much, Tom. Very kind. Was doing something, so I missed why we're not having to take the derivative for that. So basically just from sort of looking at it, but also realizing that because we're always adding positive numbers, right? So because it's the absolute T minus 3, that's always positive. So it's going to change. It's basically going to... The smallest that it could be is 4. All right? This value here is going to be 4 because it's going to be a positive number added a positive number always. And we got told the graph looks like this. Arguably there is other ways of looking at it, but basically it's like, when is it going to change? And that's when this first term is going to be equals to 0. So sort of like proof by observation a little bit. There might be a more clever way to explain that. Apologies. I can't think of one. Okay, part C. So we want when NA is bigger than NB, I believe. Or NA is smaller than NB? Which way around are we doing? The range of values for which NA is bigger than NB, giving your answer in set notation. Okay. And again, NA is T minus 3 plus 4. NB is 8 minus 2t minus 6. And I'm going to be very careful about this screen. Okay, so what I want to do here is basically find when these things are equal. And then we're going to look at, so we know that they cross. Again, sort of from the thing, but also from the equations. But when you have two graphs and you want to know, so normally when they ask this sort of question, they might ask for like positive values of a polynomial. But if we have two functions, say that one and that one, what you want to look for is what is the value of those 2 points? And then the question becomes, do you want what's between them, right? Do you want the range of values between them, or do you want the range of values outside of them? And then that would be here and here. So we need to find out what those points are first and go from there. So set NA equals to NB, and that gives me T minus 3 plus 4 equals to 8 minus 2t minus 6. Okay. Oh, it's been a while since I've done modulo manipulation. So let's see what we get. So I'm going to leave that side alone for the minute, and I can see that there's a power of 3, power of 2 here that I can take, or factor of 2 here that I can take out. So 8 minus 2t minus 3. So if I take that outside of the modulus, that's fine, because 2 is always going to be a positive number. So I get t minus 3 plus 4 is equals to 8 minus 2 t minus 3. Let's copy that and take it over to the next page. They should give us another page. Nice. So this is the expression we're working with, and now our modulus on both sides is the same, which is nice. So we can take the last term on the right-hand side over, and we can take the last term on the left-hand side over. So you get t minus 3, now plus 2t minus 3 is 8 minus 4. So 3 lots of t minus 3 is 4. We get the modulus of t minus 3 is 4/3. Okay. So now we have two possible cases. Either t minus 3 is positive or t minus 3 is negative. If you remember, the graph of modulo of x looks like this. And what that means is for any value of mod x, there are two possible options. There's positive x, and then there's minus x, or minus the value. So we have two possible cases. So either t minus 3 is 4 over 3, or and in our case, t minus 3 is minus 4 over 3. Okay, so that's just from looking at this, where this is, you know, t minus 3 here is either going to be plus 4 over 3 or minus 4 over 3. So here, this would be 3 plus 4 over 3, which is quick maths, 12. Oh, brain. 13 over 3, yeah. Or t is 3 minus 4 over 3, which is 5 over 3. Okay. Then again, we have our graph of our two expressions, and they looked like this. So we had NA doing something like that and NB doing something like that. And we want the region where NA is bigger than NB. Okay. And that means that we're looking for these bits here. So we're looking for T, if this is 5 over 3 and this is 13 over 3. So T is going to be less than 5 over 3 or T bigger than 13 over 3. And then it wants it in set notation. So set notation is going to be, so we use curly brackets, T in positive reals. Such that 0 less than T less than 5 over 3. Combined with T in R such that T is greater than 13 over 3. Okay. Lots going on there. Thank you for the follow. Appreciate it. Okay. So what we have here is a load of symbols. So this is the set containing. This thing that looks like an E is in. This thing, R is like blackboard R, so you give it that like extra line or the extra thick thing, is the real numbers, which is sort of all numbers that can be written. What's the formal definition of the real numbers? That's actually thrown me. Because rationals are fractions. It's sort of like the not complex. Any value that can be plotted on a continuous number line. Come on, give me a formal. Real number that can be used to measure a continuous one-dimensional quantity such as length, duration, or temperature. It includes the rational numbers, which are things that can be written as a fraction, as well as irrational numbers, which are things like pi and e, where you can't actually ever write them as a fraction. You can do something about sequences that don't converge in the rational numbers. Yeah. Again, we're not a physicist, we're not a pure mathematician here. But basically real numbers are most numbers that you're thinking about, but just like amount of stuff. If it could be used to describe a time or a length or a measurement, that's a real number. As taught to think of reals as numbers that can denote things like distances and their negative counterparts. Yeah, exactly. That's a nice way to do it. So it's, yeah, including the negatives is important as well. I don't think that was in A-level when I was younger. Terrifying. Okay, there was one final part to this question. This is a really long question. State a limitation of the model used for company B. So again, we can sort of look at the graph and it'll give us a hint in that it's now hit a peak here and it's going down. So eventually it's going to hit 0. And it's actually worse than that where, you know, part D, MB is 8 minus 2t minus 6, right? So eventually, and n is the number of people, right? So we were just talking about, you know, reals and negative counterparts of things, but eventually this will model negative subscribers. Which is obviously not what they want. They don't want something that's going to predict that they're going to go into the negative, a negative amount of subscribers. That's less good. Okay. In this question, you must show all stages of your workings. Solutions relying entirely on calculator technology are not acceptable. Find the first 3 terms in ascending powers of x of the binomial expansion of 3 plus x to the power of minus 2, writing each term in its simplest form. Using the artipan A and using algebraic integration, oh ho, estimate the value of that, giving your answer to 4 sig fig. Find using algebraic integration the exact value of that, giving your answer in the form A, ln b plus c, where a, b, and c are constants to be found. Algebraic integration is just integration, isn't it? Process of finding the antiderivative of the polynomial rational or algebraic functions. Okay, so okay, so not like substitution. Got it. Cool. Okay, don't worry too much about that. So we have part... Oh, there is space down here. Cool. Part A. We have 3 plus x to the power of minus 2. And we need to expand that in binomial expansion. So I think they probably are going to give us something on the formula booklet, would be my guess, for binomial expansions. But if they don't, then that's fine. Binomial series. Amazing. So the first term here is going to be okay, right. So the one that we're going to want to use is so the gut reaction might be, so there's 2 different binomial expansions that they give you in your formula booklet. So you get a plus b to the power of n, but you can only use this for n in the natural numbers. So the natural numbers being positive integers, specifically the positive integers. So 1, 2, 3, 4, and so on and so forth. But you can also use 1 plus x to the power of n, where the modulo of x is less than 1, and n is in the reals. So we can't use this one, right? Because here n is minus 2. And minus 2 is not in the natural numbers, right? It's not a positive integer. However, we want to use the second one, but we need the modulo of x here to be less than 1. So what that means is we need this term, and we also need it to be 1 plus. So we need 3 plus x to somehow get morphed into 1 plus y. So what does y need to be for us to use the power, the binomial expansion? So it can be 1 plus... I think I'm doing this right. Let's just take out a factor of 3 and see what happens. 3, 1 plus x over 3. All of that to the power of 2. So just inside this bracket, done. Take the 3 out. So that gives me 3 to the power of minus 2, 1 plus x over 3 to the power of minus 2. Oh, that's fine. Cool. So we just need to solve the binomial expansion for this thing, because now x over 3 is going to be less than 1. Or we can impose that, I suppose. And then we just have this 3 to the power of minus 2 out in front. Okay, so using the expansion. And then we use our formula booklet. So we get 1 plus minus 2. And then we have that in front of x over 3 now. So wherever there was x in our formula booklet, there's now going to be x over 2. And then we do minus 2. So that's our n minus 1. So minus 2 minus 1 over 2 factorial. And then we do x, which is now x over 3 squared. And it only asks for 3 terms. Please tell me it only asks for 3 terms. First 3 terms. Amazing. Plus some other stuff. I love plus some other stuff. That's not my problem. That's what that is. Okay. So 3 to the power of minus 2. Minus puts it 1 over. Squared. 9. The negative subscriber issue reminded me of when Gangnam Style was almost the most and least watched video on YouTube. Got so many views it almost overflowed. That's actually really fun. I didn't know Gangnam Style was the one that did that. That's so good. Okay, so we get 1 over 9. 1 minus 2x over 3. Minus 2 times 3 is minus 6. Over 2 factorial is 2. 2 times 9, x. That right? That feels right. So approximately equals to 1 over 9 minus 2x over 9 times 9. No, 9 times 3. 27. And then 6 over 2 times 9 times 9 is again 1 over 27. Okay, we got lots of x squared over 27. Shouldn't the last term, did I not write x squared? Yes. Great catch. Plus some other stuff. 3 terms. Okay, so we now have our expression. Then part B tells us to use the answer to part A to estimate the value of 0.2 to 0.4 gross of 6 over 3 plus x squared dx. So that is going to be approximately equal to 0.2 to 0.4. I'll take the 6 out the front because I can. 6x. and then put in the 3x minus 2. So that's actually still equals to here. Then I'm going to substitute for this expression here with this expression here and just plug them in. So that's going to be approximately equals to 0.2, 0.4. Maybe I should have left the 6x in because I think it's going to cancel some stuff. 1 over 9 minus 2x over 27 minus x squared over 27 dx, which is then going back to approximately equals to 0.2, 0.4. Okay, can we simplify this at all? 6 over 9 is 2 over 3x minus, okay, we now have an x squared term. 6 times, so 12 divided by 27 is 4 over 9 minus, and we now have an x cubed because we've got this x at the front here that we're chucking in to the expression. 6 over 27, which is 2 over 9 dx. Okay, and now that's quite chill to integrate. So each term, we add 1 to the power, and then we divide by that new power. So we get 2x squared over 2 times 3 minus 4x. That becomes cubed, chuck the 3, 9, minus 2x. So that becomes 4, chuck the 4, 9, between 0.2 and 0.4. So we get, let's simplify it, 2 over 6 x squared minus 4 over 27 again. Yep. Minus 2 over, it's 1 over 18? 1 over 18. Sometimes you just want to use a calculator, and that's okay. I'm still here. We're still in the house. We haven't finished the paper. I'm being stubborn. I really want to finish the paper. I want it to be done. We have like 3 questions left. Evaluated between 0.2 and 0.4. Okay, so substituting that in, we get some numbers. So 2 over 6 times 0.4 squared minus 4 over 27 times 0.4 cubed minus 0.4 to the power of 4 over 18. All of that minus the same thing. So 2 over 6 times 0.2 squared minus 4 over 27 times 0.2 cubed minus 0.24 over 18 should be equal to 2 more questions after this, to be fair. I'm gonna cheat. 223 over 6570, which is 0.3304 to 4 significant figures. Okay. Part something wrong way of that question. C is then find the exact algebraic, and using algebraic integration, find the exact value, write it in the form A, ln B plus C. So 0.2 to 0.4 of 6x over 3 plus x squared dx. I believe. Yes. Cool. So we can't just integrate nicely. We can't do like, oh, well, it goes to the log because we have that x on the top. So that's really annoying. But I'm hoping we can use integration by substitution. So integration by substitution is basically saying, let's let u equal a function of x. So let's let it equal 3 plus x. And what that will give us is we can then find all of the other bits we need and go from there. So du dx is equals to 1. So du is just equal to dx. And finally, x is equals to u minus 3. So when x is 0.2, u is 3.2. And when x is 0.4, u is 3.4. Okay, so this thing now becomes the integral of from 3.2 to 3.4, because we've now doing integration with respect to u. Dx becomes du over u squared 6, and x is u minus 3, u minus 3. Nice. Okay, so this integral is equivalent to 3.2 to 3.4, 6 over u minus 3 over u squared du. Yep. Which becomes, okay, so u minus 1, add 1 to the power, it becomes 0. So this becomes log 6 ln of u minus 3. So u to the minus 2, you add 1 to the power, so that becomes u to the minus 1, and you divide by that new power, it's divided by minus 1. And we evaluate that between 3.2 and 3.4. So what we get sorry, I should have put the 6 inside the thing here. So that actually becomes 18. Yeah. And then the minus 1 cancels with the... so it becomes plus. So plugging in our values for that, we get 6 ln of 3.4 plus 18 over 3.4 minus 6 ln of 3.2 plus 18 over 3.2. Okay, we can do log laws. So subtracting log laws, subtracting logs is equivalent of dividing them. So we get 6 ln 3.4 over 3.2 plus 18 over 3.4 minus 18 over 3.2. So that's 6 log something, I'll deal with that in a minute, minus 45 over 136, and 3.4 divided by 3.2 is 17 over 16, and it said we could leave it in that form. So that's the end of that question. 6 log 17 over 16. Out of morbid curiosity, I want to see how far off the approximation is. .328, and the approximation, so taking the binomial expansion, 3304. So 0.328 to 0.33. That's pretty close. So that's quite cool. But this is the answer that it wanted. Okay, so we didn't need to do more than that. It's just nice to see. It's just nice to see. I hope everyone's been able to... We've been going for 2 hours. If you haven't had a drink or looked after yourself or stretched, please do all of those things. Please, you know, the maths isn't worth it, I promise. We've got 2 more questions left to get through. Hoping they won't take abysmally long. However, they are the final questions of the paper. So naturally, they do sort of amp things up a little bit. And we have some trig functions. Everyone's favorite. So, show all stage of the working, relying entirely on calculator technology, not acceptable. Right, show that the equation that may be written in this form where a, b, and c are constants to be found. Hence, solve for between a given range of values, the expression. And it's the same expression, which is nice. Give me some SOHCAHTOA. Unfortunately not SOHCAHTOA, but we are going to use some other trig functions. So immediately, whenever I see these sorts of questions, my gut reaction is to go in and sort of like make sure I remember all of the tools that I might need for the problem, right? Like it's always is the question of when you start building like IKEA furniture, do you just start immediately or do you go find the screwdriver first? It's that vibe. This looks like double angle. Yeah. So things that are useful in this sort of expression. We've got the sine. So I'm just going to use S. Please stop. Sine over cos is equals to tan. And sine squared plus cos squared is equals to 1. Are both always true. The other ones that are going to be useful are going to be, as you say, some double angle stuff. Particularly, so we have, as you say, double angle. So that's why we've got two lots of it. So if we go into our formula book, so it doesn't give us double angular, but what it does give is sine of A plus B is sine of A cos of B plus cos of A sine of B, which when A and B are the same, so sine of 2 theta in this case is going to be sine theta cos theta. 2 sine cos theta. 2 sine theta cos theta. Oh, said that too many times. And when it's sine, it stays the same. When it's cos, more complicated stuff happens. Oh, no, it doesn't. It's fine. Okay. So that got us that one. So sine of 2 theta. And then the other one that's probably going to be useful is because we've got tan squared. It does not give us, I think. Have I made up the tan squared one? Tan squared is 1 minus sec squared? No, 1 plus sec squared. We can get there anyway, even if I've forgotten. So we got sine squared. If I divide everything by cos squared, then we get cos squared over cos squared is 1 over cos squared. So that goes to tan squared, that goes to 1, and that goes to sec squared. Yeah, okay. So t squared plus 1 is 1 over c squared. Might come in handy, might not. We'll see how it goes. So those are the formulas I think we're going to need. And just for consistency, I'm going to write them all like that. Leibniz is doing it with exponentials. I wish you luck. Okay, so show that the equation may be written in this other form. So immediately my gut reaction in the form we're trying to aim to has a cos squared, cos, and a sine of a double angle. So let's try and get rid of all of the tans. I think that's the most like natural thing to try and do at this point. Outside of like, you know, running and crying. So two tan theta, 8 cos theta plus 23 sine squared theta is, I can't not say it in an American accent, and it's something that, like, my Greek letters, I'm gonna blame my supervisor, who had an American twang. But beta and theta don't sound right outside, like, you know what I mean? Theta. Beta, yeah, no, I'm not saying, beta. 1 plus tan squared theta. Okay. So immediately I'm seeing, well, I just had tan squared plus 1 over here, so I'm going to swap all of this with 1 over cos squared theta. So that works fine. And then I'm also going to swap this for a sine theta over cos theta, because I think that will come in useful. So if I do both of those substitutions, I get 2 sine theta over cos theta, 8 cos theta plus 23 sine squared theta. equals to 8 sine 2 theta over cos squared theta. Okay, so we've got over cos on one side and over cos squared on the other. So I'm gonna multiply everything by cos squared to try and get rid of that. So we get, so this cos theta on the bottom becomes just a 1 cos theta on the top. And the cos theta on this side goes away. Okay, so... oh no. I have no idea what the Greek letters are going to sound like in a Welsh accent. Why have you done this to me? So we've got this 2 sine theta cos theta. And for some reason I just got rid of the equals. So there's an equals there as well. So 2 sine theta cos theta, as we said, is sine of 2 theta. And then we want sine squared. We want cos squared. Because up here, it's got cos squared, not sine squared. So we need to put that in as well. So we've got sine squared is 1 minus cos squared theta. So if we do both of those substitutions, I think we're going to get rid of a sine 2 theta somehow. Which concerns me slightly. Oh no, it is equal to 0, so we just take everything over and then it's fine. Okay. So we got sine 2 theta, 8 cos theta, plus 23, 1 minus cos squared theta, minus 8 sine 2 theta, equals to 0. So everything has a sine 2 theta in it, so I'm going to put that out the front. Then we have 8 cos theta plus 23 minus 23 cos squared theta minus 8 equals to 0. So you get sine 2 theta, which is nearly what we want to be at. Minus 23 cos squared theta plus 8 cos theta. 23 minus 8 is 15. Equals to 0. And now the question is, yeah, A, B, and C are constants, so that's fine. There we go. So that's the expression that we needed to find. We then get hence solve. So I'm gonna copy this over to the other page. So between 360 and 540, it says, the expression above. Part B, I'm just going to swap theta for x, because we know the expression's the same. The expression is the same, isn't it? I'm going to check, because I'm absolutely not with that. So you've got tan of 2, 8 cos plus 23 sine squared, 8 sine 2, 1 plus tan. Right, it is the same. So we can do it. So we got solve for this thing, solve x. I'm going to just swap all the signs because I can there, because it'll make our lives easier. Cos squared x plus 8 cos x plus 15 equals to 0. Right, so you got two things multiplied together equals to something. Sine 2 of x is equals to 0, or 23 cos squared x plus 8 cos x plus 15 is equals to 0. Okay, so if sine of 2x is equals to 0, then, so sine, remember, we've got, looks like this. And it sort of keeps going. So that's 360. That's 540. That's 540. Okay, so we're only looking between these two regions here. Okay. So in the case the sine of 2x is equals to 0, either x is equals to 360 or x is equals to 540. So that gives us our like very edge points. Okay. Or we have a quadratic equation. So we're going to let u equal cos of x. Then we're solving 23u squared plus 8u. I've lost a minus sign somewhere. How have I lost a minus sign somewhere? Where's it gone? Give it back. Minus plus plus. So that should be plus minus minus. Plus minus. Minus. There we go. Plus minus minus. Plus minus minus. Stop saying it in a minute. Minus 15 equals to 0. And then we solve that for u, and then we solve that for x. There we go. We had a mistake. We found it. We're all good. So we solve this for u. Gross. Please tell me the difference between 23 and 15 is 8. It is. Fantastic. So we get 23 u. We get just 1, innit? U, 1, 15. So that gives us 23u, 15u, minus 8. So we get minus there, plus there. They're different, plus. So 23u squared, minus 23u, plus 15u gives you minus 8u, minus 15. Right, there we go. So we get u is either minus 15 over 23, or u is 1. Which gives us cos of x is minus 15 over 23, or cos of x is 1. Now, cos looks different to sine. So cos of x does this. Okay, so that's going to be 3... No, stop it. That's going to be 360 now. And that's going to be 540. So, cos of x is equal to 1 between 360 and 540. That's going to be x is 360 again. Okay, which is the same answer that we already had before. And then the other one we have is cos of x is minus 15 over 23. So we'll do x is cos minus 1 of 15 over 23. But that's not going to give us the right region. Right, I'm currently in radians as well. So you've got to make sure that you turn your calculator to degrees or radians. They're different. So inverse cos minus 15 over 23 will give me 130. So if I add 360, that should then give me the right range. So that's 491 degrees. Okay, so my possible values of x are 3... Again, I'm using set notation here, see? But now set notation, just listing the numbers. So 360, 491, 91, and 540. Are my possible values. And even though we had 4 possible options, right? We had 2 answers from this one, and we had 2 answers from this one. One of them's the same, so it doesn't really matter. So we only have 3 values at the end. But there we go. We solved it. Hello, Cap. Final question. They're making me do a Welsh accent. I've forgotten how long I'm supposed to have it on for, so we're just going to keep going. What is the final question? Give me something fun. Go on. What have we got? More trig! Everyone loves trig. Like everyone hates Chris, everyone loves trig. I might be lying. A student attempts to answer the following question. Given that x is an obtuse angle, so obtuse greater than 90, between 90 and 180, use algebra to prove by contradiction that sin x minus cos x is greater than 1. Right, the student starts the proof with assume that sine x minus cos x is less than 1 when x is an obtuse angle. Therefore, sine x minus cos x all squared is less than 1. The start of the proof is below. Complete the proof. Okay. Assume that sine x minus cos x. So this is the contradiction-y bit, right? So obtuse, x is greater than so things that are important to know for this. Obtuse means that x is between 90 and 180, which means that sine x, draw the right one, and cos x, my sine was so nice and then my cos was just really awful. Right. There we go. Close enough. Okay, so between 90 and 180 is going to be this region here and this region here, right? So all we're concerned with is x between these possible values. Sine x, cos x. Okay. So that means that sine x is always going to be greater than 0 and cos x is always going to be less than 0 when x is a obtuse angle. So what we can do is expand this out. And basically we're trying to show that because of these two rules, right, because it's an obtuse angle, this can't possibly be less than 1. Let's see what happens. So therefore, sine x minus cos x all squared is less than 1. I'm just going to write out their line again, and then I'm going to expand it. So I've got sine squared x minus 2 sine x cos x plus cos squared x is less than 1. I'm going to use sine squared x plus cos squared x is always equal to 1. That's an identity. So I get minus 2 sine x cos x plus 1 is less than 1. So minus 2 sine x cos x is less than 0, right? So subtract 1 on both sides. I can divide both sides by 2, and that will get rid of that. And I can also divide both sides by minus 1, but that then flips the sign. So basically, if the negative of something is less than 0, the positive of it is going to be greater than 0. So that gives us that sine x cos x. So that implies this, which implies this, which implies this is greater than 0. And this is our contradiction, right? Thank you for the follow. Welcome, welcome. Okay, aggressively contradiction. So as x is obtuse, remember up here, sine x is greater than 0, but cos x therefore sine x cos x must be less than 0. Okay. So whenever you have a positive number multiplied by a negative number, it becomes a negative number, right? Positive and negative goes to negative, positive and positive goes to positive, negative and negative goes to negative. It's a negative number, which means that this is a contradiction, hence, what was the initial thing? Sin x minus cos x. Sin x minus cos x must be greater than or equal to 1. For obtuse. Yes. That's actually really nice. I think to finish off an exam and have like a, right, now finish a proof. Like you don't have to do the proof, but you have to finish it. That's really lovely. And that is the end of the exam. Amazing.